So what we have here is a Bally Midway pinball machine from the 80s, early 80s, and what I've done is I've taken the glass off of this, but I haven't really done anything else to it. And this originally, my uncle has had this since the 80s. He got it from the guy who owned an arcade, and then the arcade closed down, and then he bought a bunch of the machines real cheap back in the 80s. And he had this inside his living room for maybe 6 months, and then he put it out in a shed in his backyard, and it's been there for the past probably 30 some odd years. Okay, and this was just covered with dirt. It's still got a bunch of dirt on it. Some of the plywood that the machine is made out of is wrinkly and kind of delaminating. I'm going to try to fix that, but that's not a major priority. Making sure that the game works is the main priority. And because it's been setting for so long, I can give you an example of how I'm going to end up having, some of the stuff I'm going to have to do in order to rebuild this thing. All of the rubber pieces that were on here are completely deteriorated. Now there's some pieces have warped and twisted, and these I can actually fix in the oven. Okay. But right here we have a rubber band, okay, just like right here, and you'll notice that if I try to stretch it, it just basically breaks. So what I've done is I've ordered all of the rubber pieces that I need in order to restore this. I'll probably get those in about 5 days. But this is just, it feels like a hardened Play-Doh, this rubber right here. But all of this stuff I'm going to end up cleaning up real well. So a lot of this I'm going to have to take apart in order to replace all this stuff and clean it up real well. Okay, let me take off this one last section here, and I'm putting all of these pieces, that thing's in there good. I'm putting all of these pieces in the coin box so I don't lose any. And what we're going to do is we're going to turn this guy on and see what kind of action we end up getting out of this machine here. Okay, so it looks like there was a mouse or a rat or something that was inside here, and it's possible that some wires have been chewed up. And underneath this we've got our solenoids, and they're really loose. There's screws that are really loose on this. So I can actually work with this stuff. Okay. These solenoids are moving with ease. So it's not like it's rusted. Everything in here looks pretty good. And I think what I've done, honestly, is just tightening up a few things on here. Because we have a screw missing right there. Right? And then there was some other stuff. Remember when I said it was kind of loose? So there's like a couple things like that, but I'm sure all the screws and everything are down in here, so I'll be able to find them. And I have to vacuum in here. We have a power supply right down here on the base, and this power supply is going to be the very first thing that I'm going to end up checking. So I'm removing pieces like this. The screws for it are just normal, like wood screws. This really is just giving me access to some of the lights right here. This right here looks like it's warped, and you know, this has been in a shed in Arizona, so this has been temperatures going high, going low, high and low, and so I'm expecting to see some warpage on some of this plastic, and I mean, I've definitely seen it, but like I said, I can fix that in the oven. I should be able to flatten it without too much problem. Some of these like little plastic nuts here on the top have broken because they are rotten. Worst case, I can just use regular nuts. This looks like they're 632. At least that's what it looks like from here. I could probably get me one of those if I look online. Somebody probably sells them. You know, I just don't know who. This is my first pinball machine restoration. So I'm not completely sure. But you see how this is kind of bent? I think I can flatten that inside the oven without damaging it. Okay. We got a couple of steelies here, a couple of the pinballs. Got a huge ass, oh, we got 2 pieces of rubber right here. And rotten, absolutely rotten. Okay. We've got a piece of rubber here, back there around that. We have a bunch of little pieces of rubber as well. Kind of like on these little metal posts sticking around. That one. A lot of these pieces look like they need to go into the oven and be flattened. And because this is like plexiglass, it should flatten with no problem. And it shouldn't mess up any of the pictures or anything on it. Yeah, some of these areas it kind of feels like I need to take the air compressor to it to get a lot of the junk out, a lot of the dust and everything. But the vast majority of it I was able to clean up and get the dust out of there. You can't just call that good, okay? Because we don't know if these are actually making good connection. So we have to do this to all of them. We take our volt or multimeter, set it here. I have it set on diode. So when I take these two, we can hear the beep. And I'm going to stick these in the rear of both of these, trying to hear a beep. Okay? And so, right there. Okay? So I know that those 2 wires are connected. Okay? And I'm going to do this to all of them. And sometimes it's hard to get in there. And if you can't get in there, what you do is you just stick like a thin wire, like from a resistor, like a lead or something, down in there so it can touch. That's good. That's good. So we know that those are connected. We don't have to worry about that having a loose connection. And I'm going to do this for every one of these wires because it's really important that we have good connection. If you have one of these wires and all it takes is one not make connection, it could give you symptoms like you have a bad CPU, like a bad, in this case it's an MPU, okay? Or it could give you symptoms of maybe like you have a bad squawk and talk, which is the soundboard for this, okay? It can give you all sorts of bad symptoms, just having one loose wire. So one of the very first things you do when you are trying to troubleshoot a arcade game or pinball machine is check the voltages. Okay. Now this particular one, this is embryon. This is bally parts and stuff. And one of the very first things that I did that I found was wrong is there was a fuse blown. Okay. Now you can pop the fuses out and check each one of them. That's really the best way to do it, is pop the fuses out and check them individually. In this case, I'm just going to end up taking my multimeter here. And make sure the power's off, guys. Unplug it when you're doing this, okay? And I'm just going to check on both sides of the fuses using the diode tool. Okay? Because that will tell me there's continuity between these two. And like I said, it's usually good to actually pop the fuse out, but I'm going to show you something. This fuse I popped out, and now by testing these 2 points, we're not getting anything, but here we do. And then that's why I know I can get away with doing it the way that I did it. Okay. So that's the first thing. So we know the fuses are good. Now we have to check our voltages. And got a flashlight here to make it easier for you. You're going to see that we have a test point 1, test point 5, test point 3, test point 4, test point 2, and somewhere around here there should be, let me see, 1, 2, 3, 4, 5. Somewhere around here there should be a ground. And I am either blind, oh, here it is. Right here is our ground. Okay, so we're going to be testing these. Now, in order for us to test this, we're going to have to turn our power on. We're going to have to plug it in. I'm going to push it this way so you can see what I have on the multimeter. I'm going to be testing both AC and DC, but at first we're going to be doing DC. And DC is pretty much the vast majority of this, except for I think the fourth test point. I find when things have a ground, it's kind of annoying to constantly have to hold this to ground. So I'm just going to put an alligator clip on both ground and on my ground lead and bring it over here. Okay. So now the only thing I have to do is touch this. During the time that I'm doing this, I'm going to do everything I can not to touch any metal. Okay. I don't want to become the ground. So let's go ahead and turn it on. During this time, it also probably wouldn't hurt to actually end up popping some of these guys off, but I'm really worried about that. So let's go ahead and turn this on. Okay. And now what we're going to do is we're going to test point 1. Test point 1, depending on what board it's going to be, is going to either be 5.4 volts or 6.5 DC. So test point 1 is right here. And I am getting 6.75. Okay, that's a little high, but it's supposed to be 5.4 or 6.5. Okay, it's a little high though. Okay, so number 2, the test point 2 should be 230 volts. And here's test point 2, 235.6. Okay, the next one is test point 3, and that should be around 11.9. So test point 3, we're getting about 15. We're getting some high voltages here compared to what's supposed to be here. A little variance is okay, but a lot of variance is kind of like, eh. So 4 we're going to skip because that's AC, and then we're going to go to 5. And 5 is 43 volts DC. Okay, that one's good. Okay, so now we're going to switch to AC. And we're going to end up going to test point 4. And test point 4, we're getting 6.35, and we should be getting 7.3. So it's like 1 volt. Now when we turn this on, we have an LED right here. And it's supposed to give us a quick flash. That quick flash is basically just telling us that there is power going to the board, everything kind of charging up, and then we should see 6 flashes afterwards. Okay, so let's go ahead and do that. Let's turn this on. We got a quick flash and we have 1 flash. We have 1 flash. That's not real good right there. Okay, so we have power going to it though. That's a start. Okay, same scenario. If we look over here at the MPU, aka CPU right here, it's going to have test points on it. And on this particular one, ground is test point 4. So we have to look for it. We have test point 5 here. Might as well start looking for these fuckers now. There's test point 5. Here's test point 4. This is ground. Okay, and I want to find these other ones so I'm not searching for it. Here's test point 2 and test point 3. So we have test point 4, 5. The only one that we're missing is test point 1 right now. Let me get a flashlight. It's going to make my job a little bit easier. My vision isn't very good right now. Here's test point 1. It's right underneath the alligator clip. Okay. So now that I know where all those bastards are, let's go ahead and put the multimeter in a spot that everybody can see, which will be right here. And everything that I'm going to be measuring here is going to be DC. So I don't have to worry about the AC anymore. Alligator clip onto the ground. And let's go ahead and do this. Let's turn this on and see what we got. Okay. I'm also going to end up getting let me get a pencil so I can write what these are actually at. So test point 1, we should be getting 5 volts. Okay. Test point 1 is right here. We're getting 5.16. That passes. Okay. Test point 2, we should be getting 11.9. Test point 2 is right here. It's a little high. 14.12. That's a little high. So let me write that down. 14. Okay, that's a little high. 3, we should be getting 21.5. 22, that passes. Okay. And number 5, we should be getting 5 volts. And we do. So the only one that's a little strange is test point 2. And we need to figure out what that goes to. Okay, because that does seem a little bit high. It's almost like, once again, we might be dealing with something that just simply doesn't have that voltage drop because there's something that there's a open wire somewhere. There's an open connection, and we're not getting that voltage drop of that like 3 volts or 2 volts or whatever. Okay, so but that's the only thing that's really sticking out right now. Okay, so we also have the voltage regulator and solenoid, which is right here. And these, once again, we're going to be dealing with with DC current, and we have to find these test points on here too. And we also have our ground. And be very careful around this because there's some pretty serious voltages on this board. Okay, so let's go ahead and test the voltage regulator and solenoid board. Once again, I've got my alligator clip hooked up to ground. And it says ground on there. Let me get my flashlight so I can see where these test points are. Okay, here's one right here. It says test point 7, 6, 3, 5, 1. Let me see. There's test point 2. Okay, so test point 1 should be 5 volts, and this is once again all DC. And let me see if I can see these again. My vision is really bad right now. That is, test point 1 is right here. And this is supposed to be 5 volts. We're getting 5.18. That's acceptable. Now we're going to do test point 2, which if I'm not mistaken is 190. Okay. Test point 2, which is right here, should be 190. It's a little low. It's a little low. It's, voltages within 10%. I'm going to say that's, 170. 10%, you're dealing with 17. It's a little low, but not super low. Just a touch, okay? So that's something that I'm not completely sold on that being bad, okay? I'm not completely sold on that. It's a little low though. Okay. Now let's see. Test point 3 is 5 volts. Where in the hell was test point 3 again? Right here. This is supposed to be 5 volts. That's acceptable. And test point 4 is 230 volts. And where are you, my friend? That's test point 6, that's 3, that's 5. Test point 4 is right here. That's 230, exactly like it's supposed to be. Test point 5 is 11.9. Okay. And 3, Test point, I believe this is 5. 1423. Okay. That also is giving me the 14 volts, okay, that we were getting on the MPU. Okay, I mean the MPU was giving me like 14.12 instead of the 11.9, and this is giving me 1423. Now, once again, we're dealing with 10% tolerance, so that's only 1.1%. I mean, not percent. So if we have 11.9, we'll just be generous and say 12. That should only give us no more than 13.1. This is giving us 14 plus, so that's giving us closer to 20% voltage. I'm thinking that's because some power is not going somewhere, right? I'm thinking that's why we're not getting that voltage drop. So let's go ahead and continue down testing all of these voltages. We're going to come over here and move this guy and have it touch the squawk and talk, and then we're going to pop the ground off of here. And let's go ahead and we've got an auxiliary lamp driver right here, okay? And there's really only one thing I need to test, and so I'm not going to hook the ground up to this, but test point 2 is ground, and lamp 1 is should be 5 volts. Okay, so we're going to come over here. I'm getting 5.24, so the voltage on that is good. That was easy to test, okay? We have our lamp board. This is our lamp driver, and there's only 2 things we need to test on this, okay? And we're going to be dealing with the same thing. Number 2 is ground, number 1 is 5 volts. And I have to find these test points. Test point 1, test point 3, test point 3, ignore that one. Where is test point 2? Man, those are all corroded. Look at that. You see all that? That's from the battery leaking. Battery was up here and it was leaking down on top of those transistors right there. You know. But the lights haven't been giving me a problem, so I'm pretty sure that that's not the issue. But I can't find test point 2, which is ground, which is right there. Okay, I was having a hard time finding that. So, come over here, we go to ground, test point 1, 5.24, that's good enough for me. All right, bring this on over here. When I had first turned this machine on, I was getting some lights and stuff, so I know that these lamp drivers and stuff are working. Whatever's driving them is not, okay? For some reason that MPU just doesn't want to kick on. Something's not right. So now we have the squawk and talk. And the squawk and talk, I'm going to go ahead and I'm going to hook my ground wire back up again. Okay? And the ground wire on this is 1. Test point 1. And test point 4 is here. This looks like, I'm not sure what the hell that is right there. The way that they wired that, it's kind of strange. Let me get this and move it up like this so I can see it. Test point 1 is here, and this is our ground, okay? And some of these are going to be for output, okay? So if we hooked up an oscilloscope or maybe like a logic probe or something to it, then we could see something. But right now we're just checking voltages. So number 2 should be 5 volts. And we got to find test point 2, which, where are you at? Here's test point 5. Here's test point, man, my vision is so bad right now, it's not even funny. Here is test point 9. Here's test point 10, test point 12. Here is test point 8. This is test point 7. This is test point 5. Here's test point 3. Here's test point 5. So what the hell is that? If that's not a 5, I can't, oh, that's 6. Okay, so if this is test point 1, test point 2 has to be nearby, because right over here we have 5, 3. Here's test point 2. 5 volts. Just as the man said. Okay, test point 3 should be 11.5. And test point 3 is right here. That's acceptable. Okay. Test point 4 is a negative 5 volts. And I had seen that test point 4 just a minute ago. That's acceptable. We're going to be checking for ripple. And what I'm going to do is, once again, I'm going to take my ground there. And I'm going to turn this on, and I'm going to be looking for a little bit of ripple current. This is a filter capacitor that basically is supposed to filter the 5 volts and send it to the MPU. Well, there's a bunch of AC inside there and everything. It's going to be sending this some bad juice, right? And that's no good. It can affect a lot of things negatively. So we want to make sure that this is okay. Now these capacitors need to be replaced. They're old, okay? But let's go ahead and turn this guy on. And we shouldn't be seeing too much ripple current here. 0.2, 0.3, basically. That's fine, actually. That's okay, you know, for the ripple current on that. That's actually okay. For it being an old capacitor, that's actually all right. So I'm gonna pop this off and take it over to where I usually work on all this stuff and examine a bunch of this crap. And also look at some of these ICs like this 74LS 14 and stuff like that. I might have some of these. Maybe a diode, maybe a capacitor. Yeah, maybe a capacitor. I'm gonna check this. I'm gonna take these ROMs out, and I'm also gonna check these. I'm gonna check these ROMs and see if everything's good to go on these. During the time that I'm testing all of this stuff out, I've got things to basically redo the playfield here, and before I do that, I'm going to take a magic eraser, Mr. Clean magic eraser, and I'm going to use it on this to try to clean it up. Let's see how well this actually works. Yeah, it's taking junk up. So, because of the corrosion from that leaky battery, I think I'm having some problems. I'm thinking I'm getting some bad connections. And I want to reflow a few things, but with corrosion, I'm not going to be able to do it. So, I've got rust, I got corrosion, all sorts of things. So I'm going to end up cleaning a bunch of this corrosion and stuff away. And on the front it doesn't look too bad, but on the rear you can see it. It's real bad. And it's affected quite a few things. It's been affected like over here. Over here wasn't a bad area that I started working on. But you know, like there's certain areas that I want to reflow, but it needs to be cleaned. Okay. So the first thing I'm going to do is I'm going to turn this way, and I'm going to put some baking soda and water on this. And I'm going to scrub it with a toothbrush to try to get all that stuff up. And then after that, in order to get the rust up, I'm probably going to use vinegar. I'm going to be leaning towards the corrosion that was on this board is what's causing the problem. And this is going to be a pain in the ass. So I've got my desoldering tool plugged in, and you'll see that there's some areas that I had touched up some solder, but the corrosion was so bad that I couldn't get a real good connection. So what I'm going to do is I'm actually going to start removing components, and I'm going to end up trying to sand and retrace and do everything that I need to do in order to get this guy back to normal. Now I've been doing a bunch of desoldering here, and I went ahead and I've desoldered all of the sockets because it's good practice on old games to replace those. I've also gone around on some of these jumpers, some of these pins and stuff like that. Not jumpers, but some of these pins, and I've desoldered some stuff. On this particular one I didn't, but I know I've done it. Oh, here they are, like in areas like this and stuff. And in the areas of the corrosion, I've done the same thing. I try to desolder as much as I could, so I can pop out some of these components. And I'm going to try to remove these. I'm going to try to remove these as much as I can, so I can kind of sand and clean, and then put either new ones or replace these guys. I don't have a socket for this particular IC, but I can make one, so that's no big deal. As far as these other ones, I do have sockets. With all that being said, I'm going to go ahead and start removing some of these components. I'm going to start removing some of these sockets. I'm going to try to clean this up as much as I can. I'm going to start testing some of these areas where this stuff was corroded to see if it's any good. If it is, fine. If not, I'm going to replace it. So just give me some time, and then I'll turn the camera back on. I wanted to show you something. Remember when I said I have all the sockets except for this one? Look at how those pins are corroded. Okay, that wasn't getting any connection worth a damn right there. Looking at some of these others, they looked okay for the most part. And when you end up having pins like this, you know, don't force them out because you don't want to mess up the traces up on top. You just heat it up with a soldering iron while holding it with some needle nose, and these guys will just pop right out. So that's no big deal. But yeah, this is really bad. This could explain a lot right there. So what I've done is, after I've removed those pins, I've taken some sandpaper to clean up all of that corrosion and get where I can have some bare copper. This area looks like I have to work on a little bit more, maybe right here. Okay, but I'm going to test all these. I need to make sure that all this stuff has got continuity. And then I also did it to the rear, and right here the corrosion was really bad. Now granted, there's nothing that's really connected back here with traces except for maybe like right here and whatnot, but I want to make sure all of these are really clean before I put my new pins in there. And what I'm going to do is I'm just going to take a ROM, basically a ROM socket, and I'm just going to cut the middle of it, so, and that way I can kind of squeeze them together and make them fit, and that should work just fine. Okay, so I've got the board back in, and it took me about 2 hours, maybe even longer. I wasn't really paying attention, to do all the sockets and fix traces. The corrosion actually ate away some of the traces, but you wouldn't have never been able to see it unless you popped out the ICs, the sockets. And I did that, and then I found about 3 that were busted. There's just nothing there. So this is why you see a wire jumping from here to here. And then also in the back, I have a couple back there. Now, if everything turns out, if I did everything right, when I turn this on, we should get 1 blink, basically of it powering up, and then I should get 6 more blinks saying that it's testing everything, and we should be good. So wish me luck on this, because I don't want to. 1, 2, 3, 4, 5, 6. There we go. Yes. Okay. All right. So now we're doing a lot better here. Okay. So let's go ahead and close this up. We have a digit missing here. Okay. Let's run this through a self-test. And the self-test is in the door. If we lower this, you'll see what I'm doing. The self-test is right here by the volume control. So what I'm going to do is I'm going to push this. First is the lights. And all of the lights will blink. And then that will basically tell you which lights are bad. And I had replaced every light in here except for like 5, which is on the backboard because it's the easiest to get to. Okay, that looks good. All right, let's knock these down, and that's all of them, right? Okay, so knock those down. Okay, so now we're going to do the next test, and the next one is the scoreboard. Okay, and when we lift up, let me lift this up so you can see what I see here. Okay, 1 digit missing. Okay, that has to do with that card. With that I bet you there's a transistor or something, or a wire loose or something that can fix that. But on the bottom, we also see one like little LED kind of out on the bottom right. That might be something real simple too, but then again, that part might be burned out. Okay, so now we're going to test the solenoids, and this is going to go through all of them now. Okay, on my solenoid board, this guy right here, the transistor's missing. I ordered those transistors, so when that shows up and I replace it, that should work when you use the right side over here. Okay, so let's do the solenoids, and it should count them down. 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. Okay, that's good. This is sound, and you can tell as well as I can, there is none. Okay. Okay, so the squawk and talk, we got some problems. Let me turn this up. I don't hear anything. I don't even hear the amplifier for that. Oh, the speaker's disconnected. So we can tell that the amplifier portion is good because when I turn the knob, we can hear that hum. That hum should go away when I replace these capacitors, okay? Or at least it should minimize it. After I replace all these caps, it actually might make it where we'll be able to hear some of the sounds. It's supposed to be going through the sounds. I'm not hearing anything right now, okay? It's possible that one of these ICs are bad. It's possible that, once again, where these are sitting, the sockets are bad. It's possible that these EPROMs are toast. Okay, there's a lot of things that are possible on this soundboard. Right here we have a test. I'm pushing it and I'm not hearing anything. Okay. Getting something. The fact that we're getting something makes me think bad connection somewhere. So I'm going to turn this off, disconnect this guy, and I hope I don't have to get a new squawk and talk. These things are a little expensive. I'm glad I was able to fix the NPU. That is good news. These guys, these two I can test. I can take these out and compare them to a EPROM, the binary for an EPROM. I could test those. 6808 and 6821. Okay. This is an LM and this is an LM, and I believe those are the amplifier circuits. And we saw that the light turned on, the LED turned on, but it didn't blink, and it's supposed to blink and it didn't. Okay, so what I'm going to do is I'm going to take these ICs out and I'm going to test these ICs. On a couple of these guys, I'm going to go ahead and change out the sockets and see if that makes a difference as well. Is there anything? This is a voltage regulator right here, and this voltage regulator is 8050, so what's that, 5 volts? We have a transistor here. I'm just looking for any easy part. And the caps, for the most part, look okay. And I can take all the caps out, and I can test all the caps too, just to make sure that that's not really what it is. If this switch is stuck, I guess it's possible that it could constantly be resetting. Also, we could end up having cold solder joints back here. So, oh man, it looks like I'm gonna have to spend more time taking some things apart and replacing. Hopefully I don't have to replace this damn thing. Okay, so what I've done is I've only replaced these three right here, the sockets, as well as I've reflowed these pins. I'm going to try it, see if there's a difference. If there isn't, then I'm going to go ahead and continue doing these four and just keep doing it until I get some type of reaction. So let's go ahead and turn it on. I'm getting blinking. I'm getting sound.
Embryon 5 ball.
I think we have Bush. Let me push this.
Commence.
Huh. Let me hit the test. That's supposed to go through the sounds right there. And I'm not getting anything. That hum, I've got to get rid of that. And I know that's capacitors. Okay, let me turn this off. I know those capacitors are what's causing that hum. So now what I'm going to do is I'm going to go ahead and attach this. And I think I've got this good enough until those capacitors show up. And when those capacitors show up, I can go ahead and I'll have the energy to go ahead and reflow, not reflow, but replace these sockets as well. But right now, it's like I've spent 3 or 4 hours just doing this, and it's driving me crazy. It's like I'm just glad I've gotten this far. So let me go ahead and hook this up. I'm going to check to see if I can find a loose wire here as well as down here, because those two parts of the board are the only ones that are giving me problems as far as the scoreboard goes. Okay, so for the most part, I've got this thing working. I have to wait for some caps to come in. I did change some of the caps on the sound card, hence that's why you don't hear that hum anymore. Okay, but I ended up doing that. I ended up replacing a few more sockets because the sound was kind of intermittent. Sometimes it would work, sometimes it wouldn't, and whatnot. So I ended up changing those, changed some caps. I've got some more caps coming in the mail to replace all that just to make everything good. Since this hadn't been played in a really long time, I had noticed that some of these contacts are going to end up having to be adjusted. And I'll probably have to get in there with like a feeler gauge and try to get those things to be all exact, because sometimes the ball will hit it and it won't really register unless it's hard enough. And also, I'm looking at this and it kind of looks like it's tilted this way just a little bit. So I'm going to probably end up having to level the board here. So let's go ahead and give this a shot. I'm still waiting for my transistor for that, so I can't use it when I need to. And of course I'm dead meat. Also, I'm going to end up having to take apart a couple of those digital scoreboard things, simply because there's a couple of them that are a little bit temperamental, as well as the center piece of this right here. I'm going to end up having to adjust the left side, because when it gets near the end back there, it kind of jams up a little bit. So, and it's because of the middle plastic piece that protects the bulbs that are in there, that's rubbing up against it. So there's adjustments that need to be made on this in order to get everything kosher. But ultimately, I would say this thing's working. I'm waiting for a new rubber pad for this rubber flipper. And then this rubber flipper is actually rubbing against this piece of metal right there. And so is this one just a little bit. I'm going to adjust that to prevent friction, so that way I can make sure that I get the maximum strength out of these flippers. So when I hit this ball, I mean, it really shoots it out there. I don't really like having it where it's really weak, you know. I think after I level the playfield, after I level that out, it'll be perform better, because I think this might be a little steep. I don't know for sure. But anyway, guys, that's that. And hopefully you enjoyed watching my video and you might have learned something. Every time that I repair something new, I learn something. Because there's always new things to learn. The way that somebody had, I should have nudged it. The way that somebody had designed the machine and everything like that. It's something that every game that I work on, there's something that's a challenge. I wish that flipper up there worked though. Oh, that was close. Yeah, this flipper just doesn't seem to have enough power behind it. I mean, the left does, but this right one seems to be kind of limp. So I might have to look into that. See, and right there, I had hit one of those targets and it didn't go off. Shit. So there's definitely adjustments that I have, but I think we're good. And I think I just got the new high score, 208,000. That's the new high score, I guess. So anyway, guys, and then also another thing that happened is some of the Mylar or vinyl, whatever it is, on the background has a sticker. It's starting to come off. It's just like starting to peel from the plexiglass. And I can always get a new backdrop, or just paint over that with some acrylic and just call it good. But anyway, guys, that's that. Got to do a whole bunch of cleanup on it, and also I'm going to have to do some repair on some of the wood, because the wood has been damaged on the side. But the important part is the game works. So anyway, until next time, talk to you later.